5 is very much the basics about how we can use a graph to solve equations and inequalities. So it's going to torture some of you, I'll be honest, because rather than just doing the quick, easy, how do I solve negative 3x plus 20 equals 5, because this equation would actually be very easy to solve, wouldn't it? Okay. Some of you have solved in your head, you have an answer, you're like, I'm done. Okay. However, we're kind of prepping for lesson 1.6 here is what we're doing. So that's why we're going to take a little bit more into this. But what we're going to look at is how can I graph this to get an answer? And so when I talk about how to graph this to get an answer, we're going to take two parts. For instance, it'll make a lot more sense when we get to B, or the second example here, because that one would be really hard to solve, or more difficult to solve just by solving an equation. It's doable, but it's more difficult. This one, I know, well, easy, we're going to graph it. And so when you're asked to solve an equation like this by graphing, what we're going to do is we're going to break it into two parts. We're going to break it into the left side and the right side. So we're going to break it into the left side, as in the left side is negative 3x plus 20. So we're going to graph negative 3x plus 20. We're also going to graph the right side. The right side is 5. So we're going to graph y equals 5. Okay? And then when we get to the end, we'll talk about what our solution is. So let's do some review here. How do we graph y equals negative 3x plus 20?
Do your y and x intercept.
Okay. Well, y-intercept.
Y-intercept.
What is my y-intercept? 20. Because what form is this in? Yeah, this is y equals mx plus b, right? So that means 20 is my y-intercept. What else do we know? He's just switching over. I don't think he would. Yeah, now he's just switching over. There was an issue with the announcements this morning, so I think we'll be okay. If it starts to go really bad, we'll turn off. But okay, y-intercept is 20. What else was I asking? Slope. Slope is negative 3. And what is negative 3 as a fraction? Negative 3 over 1, yes? Now, what's the problem with our graph?
There's no 20.
There's no 20, is there? I would not encourage at this point trying to just count up 10 extra off the graph. That would get really rough because we need to be, I was going to say a little more specific, a lot more specific than that. So this is where I would talk about scaling the graph. What would be a good number to scale this by? 2. Yeah, counting up, I would scale by 2s, right? Okay, so now, do me a favor. Don't just automatically put that dot up at where you think 20 is going to be without giving me some numbers on here. Okay, because unless you show me, I'm assuming your graph counts by 1s. So 2, and I don't know if I can write all these in or not, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay? If you can't get every number in, just do like every other number. Like if you would have, done like 4, 8, 12, 16, 20, that's telling you what you're counting by, right? I can figure that out. Okay, so we had a y-intercept of 20. Now, here's a decision we have to make. What do we want to do on the x-axis? Do you want to count by 2s there also? Or do you just want to count by 1s? Okay. Here's the deal. I don't know that there's a right versus wrong specifically here. I think you could go either way with this. With that in mind, you need to label whatever you're doing. Okay? So if we want to count by 1s, we could still count by 1s on this one, couldn't we? And it might make life a little bit easier when we're trying to do our slope. But if you want to count by 2s, go for it. So I'm willing to count by 1s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And again, I'm putting some labels in because my other axis counted by 2s, yes? And so now What's the slope of negative 3 over 1 tell me to do?
Go down 3 and right 1.
Okay, down 3, right 1. So I'm going to go down now. Be careful here how you count, right? Down 1, 2, 3, right 1. So that ends up in the middle of there, doesn't it? Down 1, 2, 3, right 1. That one ends up on an intersection. Down 3, right 1. That one ends up in the middle of a line. Down 3, right 1. That one ends up in an intersection, yes? Knowing what I know, I'm going to keep going a little bit. Down 3, right 1, it's in the middle. Down 3, right 1, it's at an intersection. Down 3, right 1. You can stop whenever you want at that point, but I would suggest you do more than just 2 dots. Okay. And we technically want to what? Connect those dots? Now, connecting the dots and not missing dots is important. This might be a spot where you want to think ruler. Okay? As long as you have the dots, though, that's going to help keep you in line here. Okay, you got that one graphed? What about y equals 5? What do we know about y equals 5? This is the same as saying y equals what plus 5?
X or 0.
0x plus 5. Okay, so regardless, what do we know? Y-intercept is 5 and slope is 0. You had to graph something like this on the quiz at some point, yes? Okay, how do we graph y equals 5?
Straight.
Straight line goes through 5. And since it's a slope of 0, that means it's just going to be horizontal. Don't watch what I'm doing. I'm using 7. Okay, 5 is between 4 and 6, correct? Okay. Which it does make it that it's in between 2 things. But what do you notice if you make your dots across? Yeah, did we have a dot there at 5? We did, right? So I'm going to attempt, I can't really use a ruler here on the BenQ, so I'm freehanding my straight lines and trying to make them as straight as possible. Okay. Now, here's the deal. We just did all that beautiful graphing. You move on right now and do nothing else, you're going to get this wrong. My job was to solve. Don't move on without telling me what the answer is. What's the answer?
62.
Yes. 5. 6.
5. I think it's 5.
5.
5. So that's where they intersect.
It's hard to read.
You have it on your paper.
Why it's not graphic, but
Okay.
Ours aren't as elegant as yours.
Well, they should be.
yeah, it should be.
All I did is put a bunch of dots on and, you know. Okay, so the idea we're getting is the answer is where the graphs intersect, yes? Now, that ordered pair, after some discussion, the ordered pair, I will agree, is 5, 5. Go back to your original problem. What is my solution to this particular problem? As in, what did we only have here? We only have an x, correct? So the only answer you need to give me is the x value, which is 5. That's the unusual part today, right? Because what are you used to doing when you graph 2 lines, you're looking for where they intersect, you give that value, right? We only care about the x value for what we're doing right now. Because there's only an x in this equation. If we had an equation that had x and y, then I would care about both. But I don't have that. Okay? So you're looking for the x value today. Those of you that had solved this just using basic equation solving steps, did it work out the same? It did, didn't it? Okay. Ready to try B? Or the second example? I guess I don't have it labeled, but what are we going to graph? One of the equations we're going to graph is y equals what?
X.
Oh, okay. He's going to do the 1/2 x plus 1. What's the other one?
Absolute value.
Okay. Absolute value of x minus 4. So you're taking each half, just splitting it at the equal sign, and graphing those two equations. Okay. Let's start with our absolute value. Okay. Y equals absolute value of x minus 4. You know how to graph this. This is not a Desmos problem. You know how to graph this. What do you know about this graph?
It is.
What'd you say, Logan? Okay. How do we know it's going to be a V?
Absolute value.
Valid point. You know this, right? Okay. So it's absolute value. So we know it's going to be a V. What do we know about our V? V is normally where?
Sorry.
0, 0. What do we know about this V? Yeah. Minus 4. Can you still use those green papers? Yeah. Those green papers are still your friends, or flip back in your notes. A minus 4 inside parentheses, inside absolute value tells me we're going to go right that number. So my V that normally starts at 0, 0 goes right 4. What do the sides of my V look like? Up 1 over 1. There's no number out front here acting as a slope. So up 1 over 1. Up 1 over 1. Go the other way. Up 1 over 1. Now, here's what I'm going to say. We don't have the other line graphed yet, do we? Might you need more points than this to be helpful? You might. You can always come back and extend your slopes later. Or you can put as many points in as you want right now. Because here's the deal. We're hoping these intersect at a point. We shouldn't ever be playing a guessing game. They're going to intersect at some point that I can draw. Okay? So I just did every single dot possible. Not saying you have to do that many, but it might be helpful. Okay, I'm going to attempt. Yeah, I can't draw a straight line. So you're always welcome to use rulers if you want. Again, as long as you have the dots there, that's going to be your helpful piece. And I do have rulers up there in that little basket next to the 3-hole punch if you ever want to borrow one. Okay, you got your absolute value V?
Yes.
What about y equals 1/2 x plus 1? What is it?
Well, you just got one. Your y intercept. You need to rise 1, run 2.
Yeah, because this is in the form y equals mx plus b. So y-intercept 1, slope 1/2. So y-intercept 1 means you're going up 1. Remember, y-axis is a vertical axis, right? I think sometimes we got confused on the quiz. A slope of 1/2 means I'm going to rise 1, run 2. Oh, hey, look what just happened.
Interesting.
I found it intersect, didn't I? Should I stop there? You could, but you might get something a little wrong. I would encourage you to keep going. What happens if I rise 1, run 2? Rise 1, run 2. Rise 1, run 2. Rise 1, run 2. What happened at that very last dot?
You intersected again.
You intersected again, yes. So is there advantage to continuing going with your points? Yeah. And I'm not guessing, am I? I'm not playing the guessing game of, oh, well, they intersect over there. I don't know what the value is. That's, to me, the importance of putting all the points with the slope. So, oof, that was kind of rough, but I don't know that I can make it. Okay, we'll take that one. Okay. What's your answer to this problem?
6.
So we have two answers, yes? That ordered pair is 2, 2, which means which answer do I want?
2.
The 2. This answer is
10,
it 10, 6? Which answer do I want?
smaller one.
Not smaller, the x. I'm always picking because it's the x because what's in this equation? X. So I'm looking for solutions of 2 and 10. Okay. So this is solving an equation, right? Again, we're just doing this for today. We'll get to more like where you actually are given two equations and solving those tomorrow. Okay, and then it'll be giving me the whole ordered pair as an answer. But for today, it's an introduction day. Okay, are you ready for this next page? Or for the bottom on you? The bottom of your page, next page on me. Okay, solving the inequalities by graphing. Guess what we're going to do?
Solving inequalities by
Okay, you're going to state the obvious here. Break it into left and right, two parts again. It just comes down to, in the end, we're going to have to consider what symbol is this? Which one? It is greater than. So hold that thought. In the meantime, we're just going to graph it just like we did the last one. The last two. We're just going to graph it, see what happens. Okay? So, first I'm going to graph y equals x plus 3. We got this? We have a y-intercept of 3 and a slope of 1. Y-intercept of 3 goes which direction? Up 3. A slope of 1 tells me to go up 1 over 1. Up 1 over 1. You will learn real quick. I tend to get carried away with my points. Okay? So I went up 1 over 1 a bunch of times. Also, if it's helpful, you can reverse it. We don't have the other line yet, so we don't know how necessary it is, but we can reverse it. And go down 1, left 1. So there is one of our pieces. We're going to graph that. And then we also need to graph y equals 7 minus 3x. Are you okay with that form? If you're not, realize you can always reverse it. If I reverse it, beware your signs. It's negative 3x plus 7. So what's my y-intercept? Y-intercept of 7. Slope of negative 3. So y-intercept of 7. There's my 7. Slope of negative 3 means I'm going to go down. Reverse that wording. Down 3. Right. Okay? In other words, the 3 is the up or down. The 1 is the left or right. So I can go down 3. Right 1. Down 3. Right 1. Down 3. Right 1. Really, we've already got them crossing, so we kind of know what's going on there. Oof. Okay, I'm getting the wrong angle here. There we go. Okay. Now, where do these intersect at? That point that you should have come across an intersection at is 1, 4. Okay. We are being asked a question that was an inequality question, right? So I'm not just looking for a one number answer. I'm looking for an inequality answer. Okay? And in this point, what you're trying to ask yourself is, when is the line x plus 3 greater than the line 7 minus 3x? That's what you're asking yourself. When is y equals x plus 3 greater than y equals 7 minus 3x? So when is x plus 3 greater than 7 minus 3x? Thoughts? How do we want to answer this? Logan?
X is greater than 1.
What do you think? First of all, is he using the x value? That's what we used up above, yes? We're talking in terms of x's. And here's the ideal. So we want to know, when is, on my paper, when is my purple line greater than my blue line? So here's purple, here's blue. When is my purple line greater? So when is it higher than my blue line? Does that make sense? And that's happening over here to the right of 1. And so we do want to say x greater than 1. Because right here, this section of line, that's where x plus 3 is greater than 7 minus 3x. Because it has higher y values, has greater y values. And so that right there is my reasoning for saying x greater than 1. Okay? Do we understand how to answer that? Okay. Okay. There's a typo in your notes on the next one. Yours does not read the same as my screen, does it?
No.
So you might want to make that happen. My apologies. I was just noticing that mine is a handwritten change, so I had a feeling that the pieces are the same. What's different?
Inequality.
The inequality symbol. Okay, so get that changed on your paper so you're not confused later when you're trying to figure out what the heck I did with this example. Okay, it's just going to affect your final answer. What symbol do I have in here? This is less than. Okay, let's graph. What's the first thing I'm graphing? Y equals? Y equals negative x plus 5. We're going to have a y-intercept of 5 and a slope of negative 1. Getting lots of review here, aren't you? Y-intercept of 5 means I'm going to go up 5. What's that slope of negative 1 look like to you? Down 1, right 1. Down 1, right 1. We can also reverse that and go up 1, left 1. Okay? Either way. Okay, look at the next line. Sorry. No, not anymore. C in PFP.
Didn't Simon, they put Simon in the, they could have in one month, did not do that.
No, you want normal
I
newspaper.
just want that one.
Okay. Okay. Did you keep going? Or did you just stop and wait on me? Okay, what am I graphing now? Y equals 1/2 x minus 1. Y-intercept of -1. So we're going to start by going down 1. What's my slope of 1/2 tell me to do? Yeah, up 1 over 2, up 1 over 2, up 1 over 2, and we can reverse it and go down 1, left 2. Okay. What is my question asking this time? When is, you might not need to write this down, but when is y equals -x plus 5? This time we're using less than, and when is it less than the right, which is y equals 1/2 x minus 1. So here we've got, when is my purple less than my blue? That's my colors. We have to be careful here. We have to look at this graph. Did you want to try it, Ruby?
X is less than 4.
Partially right. Tanner?
X is greater than 4
Why?
because when it gets past 4, it goes down past the blue.
Okay, so first of all, why are we talking 4? We know this point is 4, 1, yes? So they both use the x value 4. So hopefully we can all agree that it's something with x and 4. Now, and this is where I said you have to be careful, because last time it was a greater than problem and it was a greater than answer. That's not a guarantee. Okay, so when is y equals -x plus 5? So when is my purple line less than my blue line? So when is my purple line lower than, right? Less than is kind of like lower than my blue line. And that's happening right there, isn't it? Where is that in relation to x equals 4? It is to the right of 4 that is happening. And so that's why we are going to say greater than 4. Did I explain that okay? Make sense? Okay. Okay. The back side says use graphing technology to solve equations. Okay. One of our big standards often, or several of our big standards talk about using technology to do this and that. Okay, using technology to do this and that. So here the directions say use graphing technology to approximate the solutions to the nearest 10. What graphing technology do we use?
Desmos.
Desmos. So as we look at this next section, we're going to be using Desmos. So you'll want to get your iPads out to do this next section, and you can practice there. Okay. What are we going to be graphing? Just like the last set. We're going to graph the left. So I'm going to graph y equals -x squared plus 8x minus 13. And we're going to graph the right. So I'm going to graph y equals absolute value of x minus 4. One of those would be easy peasy to graph. We've already graphed absolute value of x minus 4 today. The other one, okay, takes a little bit of work. that's why we're just going to go straight to Desmos today. Now, I have a graph here, so I'll fill in the graph just so we have a visual. But you should be headed to Desmos, shouldn't you? We've used Desmos some in homework, so we're okay with it? I might pop over Desmos here in a moment, but I'm going to go ahead and do the pre-work here. If you've graphed them correctly, it's going to look something like that. But I can't tell my answers right now. This is where graphing technology comes into play, doesn't it? I don't know, do I even have Desmos pulled up? Okay, I have a problem. I guessed right. Okay, did you get it graphed? So I know it was absolute value of x, it was -4, right? So that's one of them. I just picked that one first because that was the one fresh in my mind. Negative x squared plus 8x minus 13. Okay. And you can put y equals on the front side of those. I probably should be, but you don't necessarily have to for Desmos. What do you see here? Why are we being told to use graphing technology?
Because it is.
Is that a nice, neat whole number or anything?
Nope.
No, it's not a nice, neat whole number, is it? Okay. So this is why we're being told to use graphing technology. Now, if you remember, all you have to do is touch that intersection point, and it'll pop it up, yes? I don't think I can have them. Oh, I can't have them both up at the same time. Okay. So there we go. Now, before I switch over to my other screen, what are my solutions?
Round.
Okay, round them. The direction said round to the nearest 10th. So what are those values to the nearest 10th?
3.7.
2.7 and
1.3.
5.3. Okay, so x is approximately 2.7 and 5.3.
I don't know that.
Well, what I did, and in all honesty, you don't have to get as specific here, because you would just take, for like homework in Savas, you would just take your answer from your graph, right? You wouldn't have to draw it there. So I'm not concerned. I just wanted to have something in the notes so you have something to refer to here. You know, I went ahead and put the points in, but I mean, it's that V is moved right 4. That parabola vertex is at 4, 3 if you flip it upside down. So you don't have to get, you know, incredibly specific here, but we're looking at these x values right here. And so I'm going to say approximately, because these are estimated, right? When we were looking at the other screen, we said 2.7 and 5.3. And that would be coming from those 2 points right there. Okay.
I draw some sort of parabola and some sort of beam we built in.
Sure. Here's the deal. Are we ever going to be using Desmos on a quiz or a test? Probably not, because it brings out the iPad, and that's a whole nother world of issues that I don't like to deal with. Too many cheating options there. So, okay. Have you started working on the second one?
Yeah.
Did you get your answers? You should be graphing y equals x squared plus 2x minus 1, which is a parabola again. Okay. There's my parabola. You guys use Desmos. Then you're graphing the right side. Absolute value of x plus 2 plus 2. And then it's a matter of figuring out those values, right? Now, I can just turn those graphs, I'm just going to turn those graphs off because I don't need them. Okay. Surprise, surprise. They don't intersect nicely, do they? Okay. And it looks like we have points like this. Negative 3.3 and positive 1.8. So we said negative 3.3 and 1.8. Okay, guys. Your homework is doing the same type of stuff, okay? We're practicing a lot of graphing skills, practicing how to go about this. Lesson 1.5 homework is out there in Savas. It does have a due date of tomorrow on it, okay? And then tomorrow, I believe, we'll be starting into 1.6.